All right, everybody, tonight we're going to be doing the homework video for lesson 6-4, practice and problem solving section. It says here a study is done to compare the fuel efficiency of cars. The cars in group 1 generally get about 23 miles per the gallon, and the cars in group 2 generally get about 44 miles per gallon. Compare the groups by their means. Then make an inference and give a reason the inference might be true. Remember, the inference is just some type of information you're pulling from this data. The means for group blank is less than the means for group blank. Well, they said that they gave the means, right? They're comparing here. Compare the group by their means. So they're talking, the average here was 23 miles per gallon. The average for group 2 was 44. So we can say that group 1 is less than the means for group 2. The cars in group blank generally are more fuel efficient. Well, that would have to be group 2 because they get more miles per gallon. And the cars in group blank may be smaller. Well, it's evident here, these are all smaller cars than in group 1. So we would have 1, 2, and 2 and 2 again, okay? So let's go to the next one. The dot plot shows a random sample of vertical leap heights of basketball players in 2 different basketball camps. Compare the mean value of the dot plots, round to the nearest tenth. Well, we see that if we count up all these up, and we would have to take numbers like 27 and multiply it to 3, and 25 and multiply it to 2, when we're adding these up, we'd get 303, and there's 11 dots, so we divide that by 11, and that's how we get our average. So we would get 303 divided by 11, and that's going to give us 27.5. Like that, we also would take the camp 2 and add these up. That'd be 18 plus, look, this would be 21, and we'd have 22 and multiply it to 3, and we'd add it to that, and 24 and multiply it to 2 and add it to that, and so on and so on. And we would get 268 for the total, and we divide it by the number of dots there are, which are 11 again. That would give us 24.4. So this mean value tells you that the participant in camp 1 jumped higher in general, right? Because seems like their mode over here, remember this is the one that's most often seen, is 27, while the mode over here is 22. So more of the data is gathered to the right, between 34 and 22, whereas over here between 30 and 18. A researcher divides the marbles into 2 data sets. In data set 1, the mean mass of the marbles is 13.6 grams. Remember, mass means weight. In data set 2, the mean mass of the marble is 14 grams. The MAD, which is the mean absolute deviation of both data sets, is 2. What can you infer about the 2 sets of marbles? Well, first we can say there is not much difference between the 2 sets of marbles because the mean mass in data set 1 is just slightly less than the mean in data set 2. Remember, we're talking 13.6 and 14 grams. That's only a difference of 0.4. The MAD of the 2 means that both sets of marbles have similar distribution data. And that simply means that the data isn't spread really wide. If we were to go ahead and find the range, when we're taking that difference of each one and then finding the average of it, we're going to see that they're pretty close to each other. Number 9, Brianna asked 8 classmates how many pencils and erasers they carry in their bag. The mean number of pencils is 11. The mean number of erasers is 4. The MAD, which is the mean absolute deviation of both data sets, is 2. What inference could Brianna make using this data? Well, she could say that most of Brianna's classmates carry more pencils than erasers in their bags. That makes sense, right? There's an average of 11 pencils in every bag. There's only an average of 4 erasers in each bag. Two machines, this is number 10, high order thinking. Two machines in a factory are supposed to work at the same speed to pass inspection. The number of items built by each machine on 5 different days is recorded on the table. The inspector believes that the machines should not pass inspection because the mean speed of machine X is much faster than the mean speed of machine Y. Which measure of center and variability should be used to compare the performance of each machine? Well, the median and the interquartile range. The outlier for machine Y affects the mean and range. Let's look at this data carefully. We see that we have 20, 16, 21, 18, and 19. These are pretty grouped together. But look over here in machine Y. They've got the number 2 here, and that's an outlier. It's way away from the other numbers. That's going to affect our means. So it's better to go by the median. Remember, the median is taking the smallest one away one by one until we find the middle. And if we do that to machine X, well, we take away the smallest, which is 16, and the biggest, which is 20, the next smallest, which is 18, the next biggest, which is 21, and that will give us 19. If we did it to machine Y, we would take away 2 and take away 23, take away 18, and then take away 21. And then again, we'd have 19. So the median was a much more effective way of doing it. Okay, so when they say the inspector believes that the machine should not pass inspection because the mean speed of machine X is much faster, not entirely sure that the inspector is correct. It says no, the inspector is not correct. The data shows the median speeds are equal for both machines. The mean should not be used because there is an outlier in the data for machine Y. Number 11, the dot plot shows the weight of a random sample of fish from 2 lakes. Which comparative inference about the fish in the 2 lakes is most likely correct? Over here, we've got sample from a round lake. And this is the weight of the fish that are caught, a range of 21 and 15. Well, 21 minus 15 is going to be 6. So that would be a range of 6. But a sample from South Lake shows a range of 21 minus 11, or 21 minus 11 is going to give us 10. And that's a much bigger range than 6. All right, it says, which comparative inferences about the fish in the 2 lakes is most likely correct? A, there is about the same variation in weight between small and large fish in both lakes. B, there is less variation in weight between small and large fish in South Lake than between small and large fish in Round Lake. C, there is less variation in weight between small and large fish in Round Lake than between small and large fish in South Lake. And D, there's a greater variability in the weight of fish in Round Lake. Well, C was the obvious answer. There is less variation in weight between small and large fish in Round Lake than between small and large fish in South Lake. Remember we talked about that range. 21 minus 15 is just 6, or 21 minus 11 is 10. That range is farther out in South Lake than it is in Round Lake. Well, that's it for our homework. Hope that was easy enough for you, and I'll catch you on the next lesson.